Question 26. What current will deposit 3.25 gram of zinc in 2 hours? A. 3.25 ampere. B. 2.00 ampere. C. 1.34 ampere. And D. 0.67 ampere. So generally, whenever we see question dealing with current and deposition of elements or compounds, what should come to mind is electrolysis, and more specifically, Faraday's law. So Faraday's law pretty much states that the amount of compound deposited is proportional to the amount of current being passed through the electrolytes. Yeah. So in this question now, for this question particularly, we can solve it using two ways. So let's just stick with the formula method here. So generally we have an extensive formula given as M equals MIC divided by VF. So generally M is mass, that's mass of compound or elements deposited. In this case now it's 3.25. V refers to valency. Valency in this case now, we have, since it's zinc, just we usually see zinc like this. So it means valency is what? 2. F is Faraday's constant. It has a value of 96,500 coulomb. I refers to the current, and that's what we are calculating. T refers to time, and its unit is in seconds, or it was given in 2 hours, so we have to convert that. So 1 hour is pretty much 60 times 60, which is 3600 seconds. So 2 hours is going to be 2 times 3600 to give us 7200 seconds. What else was? Okay, M refers to molar mass. That's molar mass of zinc. In this case, it is 65 gram per mole. So I think that's all. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. So now let's make I subject of formula. So we have MVF equals MIC divided by MC. So we pretty much have I equals MVF divided by MC. So inserting the values, we have 3.25 times 2 times 96,500 divided by 65 times 7,200. So inserting that, putting that in the calculation, all we have 3.5 times 2 times 96,500. Sorry, let's take a second. So we pretty much have 627,250 divided by 65 times 7,200. That's 46,800. 627, 250 divided by 46,800. We pretty much have 1.34. I think there's something wrong with the calculation. Just to double check. And 6,500. Yeah, that seems to be on point. 65 times 7,200. So 46. Yeah. Okay, an extra zero is missing. So this is our answer. So upon comparing it with the options given, it's definitely not A, neither is it B, neither is it D, but C. So option C is the correct answer. So question 27. Question 27 says neutralization involves a reaction between H3O plus and A, chlorine ion, B, hydroxide ion, C, nitrate ion, and D, carbonate ion. So H3O plus is actually called the hydrozonium ion. And whenever we hear neutralization, what comes to mind is reaction between acid and base to form salts and water. So let's take a couple of examples to see what's happening. So HCl plus NaOH forms NaCl plus H2O. We can also have H2SO4 plus say MgOH. Yeah. So we have MgSO4 plus H2O. So we are not trying to balance. Okay, let's just balance the reaction. I think that's 2. Yeah. So when looking at the acids, we can see that the common element now is what? The hydrogen ion. And in the bases, the common element is the hydroxide ion. So actually, a neutralization reaction is the reaction between the hydrogen ion and hydroxide ion to form water. However, in this case now, it's the hydrozonium ion that was given and not hydrogen ion. So the hydrozonium ion is pretty much your hydrogen ion dissolved in water. So this means that the hydrozonium ion is equivalent to what? The hydrogen ion. So we can then replace it by saying a neutralization reaction is the reaction between an hydrogen ion or hydrozonium ion with hydroxide ion to form water. So let's test if we do still. So you can actually still have your OH minus to form 2H2O. So water is still being formed regardless. So it's definitely not A, neither is it C or D. So the correct option is option B. So moving on, question 28. Question 28 says oxygen is a mixture of two isotopes with a relative, that's this and this, with a relative abundance of 90% and 10% respectively. The relative atomic mass of oxygen is A 16.0, B 16.2, C 17.0, and D 18.0. So isotopes are pretty much atoms of elements with same atomic number but different mass number. That's what an isotope represents. So generally, how we solve this now is by saying the relative atomic mass percentage composition of the isotopes. So in the case of this question, isotopes, so in the case of this question, we have the relative atomic mass to be equal to the 16.0 has abundance of 90%, so 90 divided by 100 times the mass number, which is 16, plus that of the 18.0, which is 10%, so 10 divided by 100 times 18, so we have 0.9 times 16, that's 14.4, plus 0.1 times 18, that's 1.8. So upon adding both, we have 16.2. So comparing the options, it's definitely not A, neither is it C nor D, but option B. So that's the correct option. Question 29. Which of the following is not true of metals? A. They are good conductors of electricity. B. They ionize by electron loss. C. Their oxides are acidic. D. They have high melting point. So this is pretty much an elimination type question. So the moment we get an option that is true of metals, it means that's the correct option and we don't actually have to consider all options. So A, they are good conductors of electricity. So this is obviously true. Metals like zinc, copper, and the likes, they are excellent conductors of electricity, and that would explain why they have applications in wires and all, because they're able to conduct electricity. So this is true of metals, so that's not the correct option. B, they ionize by electron loss. Ionize pretty much means formation of ions. Ionize pretty much means formation of ions. So when they say they ionize by electron loss, it means they form ions by losing electrons. So metals generally belongs to groups 1, 2, and 3. And it's the property of these groups to lose electrons rather than gain electron. So for example, we have sodium metal. It would lose an electron to form the sodium ion. So this is also true of metal. So that means option B is not the correct option. Then option C, their oxides are acidic. So it means oxides of metals. Examples includes NaO, CaO. The way to test if an oxide is acidic or basic is to dissolve it in water. So we have sodium oxide plus water pretty much forms sodium hydroxide. Same thing with our calcium oxide. We have COHO2. So, and these are bases. That means that the oxides are not acidic, rather they are basic. And remember what we said, since it's an elimination type of question, the moment we get a correct option, that's the answer. So this is false, and that's what we're interested in. So this makes option C the correct answer. And D, they have high melting points. And that's true for metals. Question 30. Neutral atoms of neon with atomic number 10 have the same number of electrons as A, O2 plus, B, Ca2 plus, C, K plus, and D, Mg2 plus. Generally, for neutral atoms, atomic number equals number of electrons. So that would explain why, in this case, neon, which is the 10th element and has atomic number of 10, actually has 10 electrons. So it means we just have to find which of the options has exactly 10 electrons. So let's start with O2 plus. O2 plus is the 8th element, so it has atomic number of 8. However, it's not a neutral atom. Due to the charge here, it's an ion, and the plus specifically represents loss of electron here. Chemistry, the plus signifies loss of electron and minus signifies gain of electron. So it means since we have 2 plus here, it gains 2 electrons. It lost 2 electrons. That ought to be minus. So it means the number of electrons for O2 plus is actually 6 electrons. For Ca2 plus, it's the 40th element. So atomic number is equal to 40. And ideally, its number of electrons ought to be 40, but since it has a charge of plus 2, it means it loses 2 electrons. So its number of electrons is actually it's 20th element. So number of electrons is actually 18 electrons. We have K plus. K plus is the 19th element, so it has atomic number of 19. But it's also an ion, and it has a charge of +1, so it's going to be -1. Remember, plus signifies loss of electron, and minus signifies gain of electron. It's pretty much the opposite. So that's why a charge of +1 means it has lost an electron to form what? So its total number of electrons is 18. And in the case of Mg2 plus, Mg is the 12th element. It has atomic number of 12. Because of its charge of +2, it means it has lost 2 electrons, so it has 10 electrons. So comparing 6, 18, 18 and 10, obviously option D matches what we're interested in. So it means option D is correct option.